Chapter 35 of Astronomy, The Science of the Heavenly Bodies by David Todd. The Little Planets. Along toward the end of the 18th century and the beginning of the 19th, astronomers were leading a quiet, unexcited life. Sir William Herschel had been knighted by King George for his discovery of the outer planet Uranus, and practically everything seemed to be known and discovered in the solar system, with a single exception. Between Mars and Jupiter, there existed an obvious gap in the planetary brotherhood. Could it be possible that sometime in the remote cosmic past, a planet actually existed there, and that some celestial cataclysm had blown it to fragments? If so, would they still be traveling round the sun as individual small planets? And might it not be possible to discover some of them among the faint stars that make up the belt of the zodiac, in which all the other planets travel? So interesting was this question that the first International Association of Astronomers banded themselves together to carry on a systematic search around the entire zodiacal heavens in the faint hope of detecting possible fragments of the original planet of mere hypothesis. The astronomers of that day placed much reliance on what is known as Bode's law. Not a law at all, but a mere arithmetical succession of numbers which represented very well the relative distances of all the planets from the Sun. And the distance of the newly found Uranus fitted in so well with this law that the utter absence of a planet in the gap between Mars and Jupiter became very strongly marked. Quite by accident, a discovery of one of the Gestat small planetary bodies was made on January 1st, 1801, at Palermo, Sicily, by Piazzi, who was regularly occupied in making an extensive catalog of the stars. His observations soon showed that the new object he had seen could not be a fixed star, because it moved from night to night among the stars. He concluded that it was a planet and named it Ceres, for the tutelary goddess of Sicily. Other astronomers kept up the search, and another companion planet, Pallas, was found in the following year. Juno was found in 1804, and Vesta, the largest and brightest of all the minor planets, in 1807. Vesta is sometimes bright enough when nearest the Earth to be seen with the naked eye, but it was the last of the brighter stars, and no more discoveries of the kind were made till the fifth was found in 1845. Since then, discoveries have been made in great abundance, more and more with every year, till the number of little planets at present known is very near 1,000. The early asteroid hunters found the search rather tedious, and the labor increased as it became necessary to examine the increasing thousands of fainter and fainter stars that must be observed in order to detect the undiscovered planets, which naturally grow fainter and fainter as the chase is prolonged. First, a chart of the ecliptic sky had to be prepared, containing all the stars that the telescope employed in the search would show. Some of the most detailed charts of the sky in existence were prepared in connection with this work, particularly by the late Dr. Peters of Hamilton College. Once such charts are complete, they are compared with the sky, night after night, when the moon is absent. Thousands upon thousands of tedious hours are spent in this comparison, with no result whatever, except that chart and sky are found to correspond exactly. But now and then the planet hunter is rewarded by finding a new object in the sky that does not appear on his chart. Almost certainly this is a small planet, and only a few nights' observation will be necessary to enable the discoverer to find out approximately the orbit it is traveling in, and whether it is out and out a new planet, or only one that had been previously recognized and then lost track of. Nearly all the minor planets so far found have had names assigned to them, principally legendary and mythological, and a nearly complete catalog of them containing the elements of their orbits, that is, all the mathematical data that tells us about their distance from the Sun and the circumstances of their motion around him, is published each year in the Annuaire du Bureau des Longitudes at Paris. But these little planets require a great deal of care and attention, for some astronomers must accurately observe them every few years, and other astronomers must conduct intricate mathematical computations based on these observations. Otherwise, they get lost and have to be discovered all over again. Professor Watson of the University of Michigan and later of the University of Wisconsin endowed the 22 asteroids of his own discovery, leaving the National Academy of Sciences a fund for prosecuting this work perpetually, and Leuschner is now ably conducting it. While the number of the asteroids is gratifyingly large, their individual size is so small and their total mass so slight that even if there are 100,000 of them, as is wholly possible, they would not be comparable in magnitude with any one of the great planets. Vesta, the largest, is perhaps 400 miles in diameter, and if composed of substances similar to those which make up the Earth, its mass may be perhaps 1/20,000th of the Earth's mass. If we calculate the surface gravity on such a body, we find it about 1/13th of what it is here, so that a rifle ball, if fired on Vesta with a muzzle velocity of only 2,000 feet a second, might overmaster the gravity of the little planet entirely and be projected in space, never to return. If, as is likely, some of the smallest asteroids are not more than 10 miles in diameter, their gravity must be so feeble a force that it might be overcome by a stone throw from the hand. There is no reliable evidence that any of the asteroids are surrounded by atmospheric gases of any sort. Probably they are, for the most part, spherical in form, although there is very reliable evidence that a few of the asteroids, being variable in the amount of sunlight that they reflect, are irregular in form, merely angular masses, perhaps. The network of orbits of the asteroids is inconceivably complicated. Nevertheless, there is a wide variation in their average distance from the Sun, as their periods of traveling around him vary in a similar manner, the shortest being only about 3 years, but the longest is nearly 9 years in duration. The average of all their periods is a little over 4 years. The gap in the zone of asteroids, at a distance from the Sun equal to about 5/8 that of Jupiter, is due to the excessive disturbing action of Jupiter, whose periodic time is just twice as long as that of a theoretical planet at this distance. The average inclination of their orbits to the plane of the ecliptic is not far from 8 degrees. But the orbit of Pallas, for example, is inclined 35 degrees, and the eccentricities of the asteroid orbits are equally erratic and excessive. Both eccentricity and inclination of orbit, at times, suggest a possible relation to cometary orbits, but nothing ever has been definitely made out connecting asteroids and comets in a related origin. No comprehensive theory of the origin of the asteroid group has yet been propounded that has met with universal acceptance. According to the nebular hypothesis, the original gaseous material, which should have been so concentrated as to form a planet of ordinary type, has, in the case of the asteroids, collected into a multitude of small masses instead of simply one. That there is a sound physical reason for this can hardly be denied. According to Laplacian hypothesis, the nearness of the huge planetary mass of Jupiter just beyond their orbits produced violent perturbations which caused the original ring of gaseous material to collect into fragmentary masses instead of one considerable planet. The theory of a century ago, that an original great planet was shattered by internal explosive forces, is no longer regarded as tenable. To astronomers engaged upon investigation of distances in the solar system, the asteroid group has proved very useful. The late Sir David Gill employed a number of them in a geometrical research for finding the Sun's distance, and more recently, the discovery of Eros has made it possible to apply a similar method for a like purpose when it approaches nearest to the Earth in 1924 and 1931. Then, the distance of Eros will be less than half that of Mars, or even Venus, at their nearest. When the total number of asteroids discovered has reached 1,000, with accurate determination of all their orbits, we shall have sufficient material for a statistical investigation of the group, which ought to elucidate the question of its origin, and bear on other problems of the cosmogony yet unsolved. Present methods of discovery of the asteroids by photography replace entirely the old method by visual observation alone, with the result that discoveries are made with relatively great ease and rapidity. End of section 35.